Welcome to the tutorial on Cramer's rule. Cramer's rule basically is a method that uses the determinants in order to solve the system of equations. And this was first discovered by the mathematician Gabriel Cramer. So we will start with the statement. We will try to prove this Cramer's rule, and after that we will proceed to solve the numericals. So the statement says that if you have a matrix A, which is an invertible matrix is the one for which inverse exists, and say for any b, variable b, in Rn, a unique solution x of Ax equal to b will have the entries xi to be equal to determinant of aib divided by determinant of a, where I can vary from 1 to n. So to prove this, we will consider a matrix A with columns which are given by A1, A2 up till AN, and we will consider another matrix that would be an identity matrix I with the column entries E1, E2 up till En. Now if Ax is equal to b, then we can write A into identity matrix II of x to be equal to A times the entries in the identity matrix. So now let me multiply this elements of the identity matrix with A, and I will get this as Ax into Aen. So the matrix A contains, when multiplied with E, the identity matrix, it is going to be equal to the variables A1, A2 up till An. So let me just take the determinants on both the sides. I will have determinant of A multiplied with determinant of Iix to be equal to determinant of Aib. Now since the determinant of Iix is equal to xi, I can write this as determinant of A multiplied with xi is equal to determinant of Aib. So rearranging, I get this statement, equation xi to be equal to determinant of Aib divided by determinant of A. Now let us look at the numerical. I have the first question which says that using the Cramer's rule, I need to solve the system of equations 3x1 minus 2x2 equal to 6, minus 5x1 plus 4x2 is equal to 8. So first let me write the variables corresponding to the matrix A. So I have 3 minus 2 minus 5 and 4. So for the determinant, I will multiply 3 into 4 minus of minus 5 into minus 2, which is equal to 12 minus 10, that is equal to 2. Let me find out A1 of B. So for that, I need to write the equation by replacing the element C with the entries in the first column of A. So let me rewrite this expression so I know that what are the elements that I have written. So the first equation can be written as a1 x1 minus b1 x2 is equal to c1. Second equation is a2 x1 minus b2 x2 is equal to c2. So the matrix A was written as a1 b1 a2 b2. So when I want to find a1 b, I will replace with c1 c2. So 6 and 8 are entered here in place of the first column, and I will find the determinant of this. So I have this as 6 into 4 minus 8 minus 2, which is equal to 24 plus 16, that is 40. Similarly, for A to B, I will replace the second column with C1 and C2. And I will find the determinant now. So this would be 3 into 8 minus 6 into minus 5, which is equal to 54. Now using the equation that we have seen in the derivation, I need to find out what is x1 and x2. So for x1 it will be determinant of a1 of b divided by determinant of a, which is equal to 40 by 2, that is equal to 20. And x2 will be determinant of a to b divided by determinant of b, that is equal to 54 by 2, which is equal to 27. So this way we have solved the system of equations and found x1 and x2. For the second problem, the question says determine the values of S for which the system has a unique solution and use the Cramer's rule in order to describe the solution. And the equation is given as 3sx1 minus 2x2 equal to 4 minus 6x1 plus sx2 equal to 1. So before that, let us understand what do you mean by unique solution when it comes to Cramer's rule. So to obtain the unique solution, there are two conditions that need to be satisfied. The first one is that the number of equations should be equal to the number of unknowns that are present. So here there are two equations that we have and the number of unknowns are 2, that is x1 and x2. The second point is that the non-zero determinant should be obtained. So that means that if I am going to consider the determinant as A, the determinant resultant should be equal to non-zero. So here let me write my matrix A. So that will be 3s minus 2 minus 6 and s. Determinant of this would be equal to 3s square minus 12. So this particular thing can be written as 3 into s square minus 4, which can be written as 3 into s plus 2 into s minus 2. That is a square minus b square is equal to a plus b into a minus b. Then I have a1 of b, for which I have to replace the elements with the 4 and 1 for the first column. So 4 and 1 minus 2s, and I will obtain the determinant of a1 of b, that is equal to 4s plus 2. Similarly, a to b will be equal to 3s minus 6. The elements are going to remain as it is. Second column elements will be replaced with 4 and 1. Determinant of a to b will be equal to 3s plus 24. Now I need to find out x1 and x2. So for that, x1 will be equal to determinant of a1 of b divided by determinant of a, which is 4s plus 2 divided by 3 times s plus 2 into s minus 2. Second one, x2 will be equal to determinant of a to b divided by determinant of a, which is equal to 3s plus 24 divided by 3 times s plus 2 into s minus 2. I can cancel off 3, which is common. So rewriting. So this becomes s plus 8 divided by s plus 2 into s minus 2. So here the question was also to find the value of s, right? So what we have basically done here is that we have computed the value of the determinant of a, right? So the determinant of a was supposed to be not equivalent to 0. So that means 3 times s plus 2 into s minus 2 is not supposed to be equal to 0. So I can write this as s is not equal to plus or minus 2. So hence what we have done is we have found out the values of s, which means that s is not supposed to be equal to plus or minus 2, and also we have solved this numerical to determine the values of x1 and x2 using the Cramer's rule.